Back. I'm trying to think of what grade you would have first seen this. I don't think Kenzie's seen it yet, but for some reason 5th grade's popping in my head. But it might have been 6th. Remember those problems where they said, and I can see the little pictures very clear in my head. You have 5 different shirts, and they'd have 5 little shirts drawn. One had polka dots, one had stripes, and you have 3 pairs of pants. How many different ways can you make outfits and this and that and other? Or how many? Okay, and you talked about hopefully combinations and permutations. Does that sound familiar at all? And so permutations were when it mattered what order you did things, like how many different ways can I award 1st, 2nd, and 3rd place to a group of 25 kids or whatever. Whereas combinations don't really, the order's not important, okay? How many ways can I choose 5 out of a group? Or let's just say our class of 22. How many different ways could I pick groups of 3 students? Okay, that's a combination. Because it doesn't matter the order. Shamik, Rosa, and Grant would be the same as Grant, Rosa, and Shamik. The order doesn't matter. Does that make sense to you? Yeah. Okay, so we're going to focus on combinations, all right? So the way it's written, you probably remember seeing something like this. No, y'all never learned it like that? Okay, it is on the calculator. What this is, N is your total number that you have. So in other words, if I'm talking about this class, my N would be 22 because there's 22 students in here, right? R is the number in your group. So if I did 22, choose, what did I say, 3 people group? Choose 3. That would tell me exactly how many ways I could choose 3-person groups in this class, okay? Now, I could show you how to do it by hand, and there's a handy-dandy little formula for doing it by hand if you want to, and I'll give it to you, but I'm not going to force you to use it. We're going to use our calculator. How many of you have seen that symbol before? What's it mean? Factorial, what does factorial mean?
You multiply all the numbers below it, like 5.
Exactly. So if it's 5 factorial, that would be 5 times 4 times 3 times 2 times 1. 22 factorial, which would be on the top here, would be 22 times 21 times 20 times 19, 8, all the way down to 1. Right? Okay. Divided by n minus r factorial times r factorial. Lucky for you, though, we're going to use our calculator. And your calculator does have a factorial button, by the way. But I'm going to show you how to do combinations on your... Y'all really don't ever remember seeing that? And then permutations. Permutations look like that.
Yeah, never saw it.
Never saw an exclamation mark.
Seriously? Y'all have never seen factorials either?
I saw it long.
Well, look, that may pop up on SAT, ACT type stuff. You may see a question that includes a factorial. Now you know what that means.
Even on the PSAT, I saw that.
All right, so let me show you because I'm going to do this. I'm going to do this strictly on the calculator. So, and I'll show you first, and then we'll do it. See the button there that says Stat?
Wait.
I think it's under there. Let me
I see it.
it's not under Stat. I'm just kidding. It's under Math, Probability.
I'm supposed to hit math?
Hit Math, not Stat, Math. I got confused. And go over to where it says PRB. And you see in there. All right. So don't do it just yet because on these calculators you have to enter the N first. So I'd have to do 22 math NCR and then my actual R.
So you said it 22
Mm-hmm.
22. Oh, I hit alpha. What alpha do?
Casio, it's still on there. There's an option. Let me see your Casio.
Yeah, I got that.
22. Math. MCR. Do you got
How many
something
groups, different kinds of groups we can have?
I got it.
Round C. Wait, what are you?
140. Now tell me this. What does that mean?
That's how many groups?
How many different combinations?
How many different groups of 3 I could choose in this class? That is a lot, right?
Yep.
You know how you go to Sonic and they've got on that sign that they advertise so many different drinks that you can have?
No, it's a combination.
That's a combination problem. That's pretty cool, right? So you'd use an NCR. But that one is even more complex because you could choose 1 flavor, or you could choose 2 flavors, or you could choose 3 flavors, or you could do, so you have to take, like if they had 25 flavors, you'd do 25, choose 1, but then you'd have to add to that 25, choose 2, because you could get 2 flavors. Then you'd have to add to that 25, choose 3, you could get 3 flavors. That's why the number's so big.
What's the number?
If you think about a word problem, kind of like a Sonic problem, okay? When we talk about how many different ways and things we can choose, okay? I always tell everybody to think about if you could put the word and in, okay? And generally for us means to multiply. Whereas the word or means to add, okay? So let's set this up. Let's say we went to Sonic and they had 25 flavors. But they told you you can only choose I should say you can choose up to 4 flavors. How many possible combinations are there of drinks if that's the scenario? So let's think about it. 25, choose 4 flavors, right? Is it an or an and?
I don't know.
Can you choose 4 flavors and 3 flavors, or 4 flavors or 3 flavors? Or 3 flavors, right? You wouldn't choose 4 flavors and then another 3 because then you'd be at 7 flavors, right? So you gotta think about the way it would be worded. Does that make sense to you, what I'm saying? So 25, choose 4. Or, so I'm gonna add 25, choose 3, because they can choose up to 4 flavors, right? We might get a calculator overload on this, I'm not real sure. Or 25, choose 2.
Or 25 choose 1.
Or 25, choose 1. And I don't think they have a flavor without flavor, do they? Like you can't get, I'm not sure.
No.
Sugar water?
Okay, sugar water.
Sugar water.
All right, so my question is, how many different possibilities of drinks are there? That's not 15,000.
I got it.
All right, so if you do 25, choose 4, what do you get?
I got.
Anybody else get 12,000 something?
Let me do this.
1,
thing.
5, 2, 7, 5.
All right, let's do.
25.
That's right here.
All right, hold on. I'm gonna do it here so we got it on the video. Let's do.
I got 12,650.
I got 15,000.
I'm gonna do 25. Choose 3. Choose 4. Just kidding. 12,650. Did we all get that?
No.
No. Anthony, you didn't get it? Okay.
Okay, wait.
That's crazy that
Let me
they
see.
have that many drinks.
But in addition to that, that's just how many different ways, if there's 25 flavors, that's how many different ways I can pick 4 flavors. So grape, strawberry, watermelon, and banana. Or grape, strawberry, watermelon, and coconut. I don't know. I'm just trying to think. But you know what I'm saying? So that's what it's telling me. Yes, Ozzy.
Oh wait, was like this like 3 plus? Like usually it's like 12.
Yes, so that's not all. That's only the 4 flavors. So now I've got to take into account how many different 3 flavored drinks there are. So that's 25. Choose 3.
Wait, I thought we were going to find all of them together.
We are. So that's 2,300. Now 25, choose 2. $300. And 25, choose 1. Why don't you think about this one and tell me what you think it is? 25. You could choose strawberry or banana or watermelon or coconut or blueberry. There's no other way. You see what I'm saying? There's no way to. It's only 25 ways. Yeah.
How do they figure out? I didn't know this stuff.
That would be an additional flavor, I'm assuming.
It's 50 cents more than having an additional flavor.
I mean, they're saying like how many, yeah. All right, so let's add them all together. 1, 2, 6, 5, 0. 2, 3, 0, 3, 0. There are 15,275 different ways to make a drink choosing up to 4 flavors, given 25 flavors. Does that make sense to you? Okay. What if?
Oh, you about to do another example?
Let me read you an example out of the book so you kind of get a feel for that too. Parents,
I like carrots.
parents, not parrots.
Darn.
If you still messing with money bag?
The student council consists of 6 seniors, 5 juniors, 4 sophomores, and 3 freshmen. How many different committees can you make consisting of, groups, consisting of exactly 2 seniors and 2 juniors? If this is the whole student council here, how many different ways can you choose a group of 2 seniors and 2 juniors?
I mean, different ways.
This is just one scenario we're doing.
Yeah,
So the sophomores and the freshmen would not matter.
So my question is, should it be, all right, there are 11, 15, there's 18 in total. Should it be 18 choose 2 or should it be 6 choose 2 for the senior portion of it?
Wait, would it be 7
6 choose 2. Would it be what?
for sophomore and 3 freshmen?
Well, I just added all these. So 11 plus 7 would be 18. So, yes, because I'm saying I'm only picking from the seniors. So there are a total of 6 seniors, and I am choosing 2 of them. and is in there. Do you see the and?
Multiply.
So multiply 5,
5.
choose 2 again.
Okay.
So what's 6 choose 2? 15.
15, okay.
What's 5 choose 2? 10. How many different ways can you form that committee? 150 different ways. Which is pretty amazing if you think there's only 6 seniors and 4 juniors. I mean, 5 juniors. Does that make sense? Do I need to do any more? Y'all got that? Tanner?
Oh, we done?
Another one? Oh, I know, but you said I always move on. I'm just making sure we
Done,
did.
Mr. B?
No.
This is easy.
Okay.
It's just copy it.
Then let me show you my favorite part of this section.
Man, why you sitting so much?
Y'all ready?
You look like a 2-year-old.
So there are a lot of patterns found in nature that are numeric that we learn about. It's one of my favorites. It's called Pascal's triangle. Pascal's triangle. That has to do with Fibonacci series.
I'm so glad that
I love it.
Okay. Pascal's triangle is in the shape of a guess what?
Try.
Oh my gosh, y'all are so smart.
Yeah, everybody in this class smart.
Here's what happens. We start out with a 1. We break down from 1 to 2 numbers and we're still going to do 1. The whole outside of this triangle is going to line with 1s. We're always going to start with 1. Okay. What we do now, this is 1. We add the 2 terms above and put it in the middle below it. So in other words, what's 1 and 1? And we line it with a 1. We come out a little bit further. Now, what's 1 plus 2? What's 2 plus 1? We end with a 1.
What is this?
Pascal's triangle.
Pascal is stupid.
It's gonna be 4.
All right, so now it's 1. So 1 and 3 is 4. 3 and 3 is?
Oh.
3 and 1 is? And then we end with a.
It's like a number program.
1 and 4 is?
5, 10,
4.
10, 5.
Look at you go, Shamik.
That's a 2.
It's a cheetah. Next row.
Already wrote the next one. You just ain't even know.
Say.
20. You didn't know that, G.
I tell you what, that cheetah, we can't keep up with him.
Y'all gotta show you a video of Cheetah running for real in this school.
Okay.
Yo, he is out of here. Like,
7.
then you wanna see it too?
35. 35.
Yo, how long this trying to go?
Let's do one. Oh, it never ends.
Then what is we doing it for?
Let's do one more row, because I love it.
It's gonna be a mouth.
8.
56. 70.
Why is it suddenly easier for you? It's on the other side. So what do you notice about Pascal's triangle?
Oh, look. 1, 2, 3, 4, 5, 6, 7.
That's actually pretty good that you caught that, Shami. That wasn't what I was getting to.
1, 2, 3, 4, 5, 6, 7. Oh, I'm about to say 3, 6, 9.
It is symmetrical on both sides, down the middle.
Yo.
So once we get to the middle, it starts repeating, hey. I'll show you my favorite part about Pascal's triangle. Pascal's triangle is a listing of all possible combinations. So you could find combinations without using your calculator by forming Pascal's triangle. How, you might ask, might I do that? Well, I start with 0, choose 0. I always start with zeros. This is going to be 1, choose 0, 1, choose 1. This is going to be, this is the second row. It's going to be 2, choose 0, 2, choose 1, 2, choose 2.
You gotta do this.
Until you understand what I'm doing. This next row, 3, choose 0, 3, choose 1, 3, choose 2, choose 3. It's up to you. Okay. So if I wanted to know, looking at my triangle, what is 7, choose 3? What?
So you would have to
never
do
mind, I
7
get it.
columns.
So your key with this is you have to start with 0 when you count, okay?
So you would have to do 7 columns.
This is my row. This is how many across, but I have to start with 0. So I go down to 7, 0, 1, 2, 3, 4, 5, 6, 7. You could also note by the second number tells you the row number, okay? Across 3, remember the ones count as 0. So 0, 1, 2, 3. So 7 choose 3 is 35. And if you put that on your calculator, you should get 35. Isn't it cool though?
Yes.
Thank you, Shami. Bonus for being excited about Pascal's triangle.
Yes. Oh, I'll be extra excited next time. Next time I'm gonna be like, yes.
You broke the ceiling tile. You lost points on that.
It's not broke. It's not.
Without your calculator at all, how many different ways can you choose if you have 8 books? And of those 8 books, actually, let's say 10 books. You have 10 books. Of those 10 books, 7 are fiction.
2 are not fiction.
That would be 9. So 3. Let's say 3 are documentaries.
Documentary books?
Is that no? Give me something else besides.
I'm pretty sure that's all nonfiction.
That's yeah,
Nonfiction.
nonfiction. We'll just do y'all are so boring.
Not me.
Okay,
At least we're not sad.
7 fiction. 7 fiction, 3 nonfiction. You are doing a project for.
Is this extra credit? That's my question.
No, it's a regular credit. You're doing a project for your English class in which you must use 1 nonfiction and 2 fiction. How many different ways can you pick those books?
All right, let me see.
So
No calculator.
7.
Ooh.
C.
Do, 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 do,
1. Oh.
63.
Oh.
Oh, is that right? I don't know. I haven't worked it
Tweaking,
yet.
man. I'm reckless.
I haven't even
Man, you're a reckless lookalike.
And? You said and?
And
multiplied.
This all do. And you look like Ewok. You know him?
24.
3, man. 3, man.
are y'all sure?
63. 21.
Oh, hold on.
Where's everybody getting 63?
The triangle. We did the.
I did 2 nonfiction and 1 fiction.
You did what?
One fiction.
Oh, I see.
63.
Wait, no, I didn't.
Did I do it wrong?
You did it.
That's 63.
Oh, shameful, shameful.
Shame on you. See?
I was trying to keep up with you. 1 nonfiction, so I got 3, choose 1.
So down 3.
Times 2 fiction, so 7, choose 2. So 3, choose 1 is 3. 7, choose 2, you are correct.
That was fun.
That was fun, wasn't it? Bonus points for you. No,
Really?
No, I'm the only one that got bonus points.
You lost him.
I'm picking. All right.